In this video, I'm going to be working number 6 from the free response portion of the 2023 AP Calculus AB exam. And this one looks like it's going to be some implicit differentiation, yes. Right at the beginning there, say, show dy dx equals this. All right, so we've got 6xy, I might copy this down, 6xy equals 2 plus y cubed. And what we're going to do is we're going to take the derivative of both sides with respect to x. Okay, so the derivative, okay, we've got 6xy, and that's a product, so we're going to need to use the product rule. So think about it, red and blue. I'm going to take the derivative of red first with respect to x, so that would be 6, while leaving blue the same. Then I'm going to add, leaving red the same, that would be 6x, taking the derivative of blue, but I'm taking the derivative of y with respect to x, so that's dy dx. And that'll equal the derivative of 2 with respect to x, okay, that's going to be 0. And then the derivative of y cubed, that'll be 3y squared dy dx. That happened to me recently, so it's time, what would that be, 6x dy dx, it's supposed to be there. Okay, and now all I've got to do is just kind of like collect everything with the dy dx to one side of the equation and get rid of everything else. So I'm going to say y equals 3y squared dy dx minus 6x dy dx, factor out the dy dx, divide away the rest of the stuff, and then I'll have shown what needed to be shown. So hold on, what is going on here? Why? Oh, hold on, 6y. Okay, I don't know if that was there the whole time, or there was there and then it disappeared, or it wasn't there at all. And I was like, this is not going to end up being 2y over something. Okay, but yes, so yeah, we're going to divide everything by 3, so dy dx. Okay, in the numerator I've got 6y. The denominator I've got 3y squared minus 6x, and if I, multiply top and bottom both by a third, then I'd have 2y over 1y squared minus 2x, which is what we had set out to show in the first place. Okay, find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. Okay, well, for part B, I'm going to say if tangent line is horizontal, that means the slope of the tangent line dy dx, that's equal to 0. Okay, and dy dx would equal 0 only when the numerator of dy dx was equal to 0 and the denominator was non-zero. So that's where 2y equals 0. So that means that y has to equal 0. And then I go back to the original equation, to 6xy equals 2 plus y cubed. Okay, and then we're going to plug in y equals 0. Oh, this is interesting. So 6 times x times 0, that's going to be 0, equals 2 plus 0. And so I'm going to see that no such point exists. Okay, so I'm going to say no point on the curve. I think that this would be a sufficient reason why no such point exists, as you go to solve and you arrive at a contradiction. But I'm just going to say no point on the curve has y coordinate 0. That's really the reason. And then part C, find the coordinates of a point at which the tangent line is vertical. Okay, this is interesting. I like this problem. So dy dx fails to exist because of division by 0. That's going to be where y squared minus 2x is equal to 0. So that's where y squared equals 2x, and x is half of y squared. Okay, so what we're going to do, we're going to go back into the original equation and we're going to plug in there. And so I'm going to say 6xy equals 2 plus y cubed. X equals half of y squared. I'm going to just kind of go in, only look at this for a minute. 6x times 1/2. Wait, no, pardon me. X is y, the one that's y, 1/2 y squared. 6 times half y squared times another y equals 2 plus y cubed. Love where this is. 3y squared equals 3y cubed. Yeah, there's 3 total powers of y there. Equals 2 plus y to the 3. Yeah, and so if I subtract a y to the 3 over here, I'd get 2y to the 3 equals 2. And that's just going to mean that y to the third equals 1 and y equals 1. We've got a formula for x, and so x is going to equal 1/2 of y squared, and that's my point. Okay? And I think, yeah, that's going to be the only point, because that's y equals 1 is the only way you can get y cubed equals 1. and then x is unique for a given y. Yeah, okay, so that's the only point where that's going to happen. That's part C. It's been nice. Exciting for me. I don't know how y'all felt about it. Okay, a particle moves along the curve. At the instant when the particle is at the point 1/2 and -2, its horizontal position is increasing dx dt equals 2/3. What's the value of dy dt, the rate of change to the vertical position at that instant? Great, we can do this. Okay, what I'm going to do, I'm going to clear out this earlier work and zoom back in on the statement of the question. So I'm saying what we're going to need to do is take the derivative of the original equation with respect to time this time instead of x. So 6xy equals 2 plus y cubed. Now we're going to take the derivative with respect to time. So again, I'm going to use the product rule. So the derivative of 6x would be 6 dx dt. Okay, leave y the same, then leave 6x the same and take the derivative of y with respect to time, and that'll be dy dt. The derivative of 2 with respect to time, that's going to be 0, and then derivative of y cubed, that's still 3y squared, but this time dy dt, because of the variable we're taking with respect to. Okay, now I've got all the pieces I need, right? They told me x is 1/2, y equals -2, and dx dt, is there room for that? Just barely. Dx dt is going to equal 2/3. Okay, now our job is to plug in all of these things and find the value of dy dt. So 6 times dx dt times y, which is -2, plus 6x times dy dt, the thing we're hoping to solve for, is equal to 3y squared dy dt. Okay. Alright, so 6 divided by 3 is 2, that's -8 plus 3, and I'm going to call this y prime for the time being. Because I don't want us to make an algebra error just because of like the notation. Okay, so if I go over here, say -8 equals 9y prime, and I get y prime equals -8 ninths. Alright. Alright, that's going to be all for this video. I didn't really check my work besides on this problem just to make sure I didn't make an arithmetic error. So, if I made a mistake on this, let me know in the comments, I guess. But thanks for watching.